Hey everybody, Matt Morgan here. In this video, we're going to talk about naming chemical compounds from OpenStax Chapter 2. We'll talk about nomenclature terms, chemical naming rules, main group ions, and finish up with transition metal ions. Any specific activity, including sports or flying or chemistry, has its own language. Learning chemistry will be much easier if you know the names of the chemicals that you're working with, and it's going to be a lot more difficult if you don't. It may take some time to learn these terms, but it will be time well spent. Let's start by going over some general terms. Organic molecules contain covalently bonded carbon, no ionic bonds. We'll talk about these terms a little bit later, but just know organic contains carbon and no ionic bonds. Inorganic usually don't contain carbon, but there are exceptions and are joined by elements that are positively and negatively charged and attracting each other. Those are ionic bonds. Monatomic ions are formed from a single atom. One atom gains or loses electrons, obtains a charge. That is a monatomic ion. Polyatomic ions, two or more atoms combined to make a single ion. We've got a specific video on naming polyatomic ions, but that's what a polyatomic ion is. Multivalent atoms, and we'll talk about that a little bit later in this video, can have different charges. The transition metal ions are notorious for this. Elements such as copper can have either a +1 or a +2 charge. Vanadium can have all kinds of charges. So some other rules. Don't capitalize chemical names unless they come at the beginning of a sentence. Sodium chloride is just like car or dog. Don't capitalize it just because it's a chemical name. Always capitalize the first letter of an atomic symbol. Positively charged ions have the same names as their parent atoms. Potassium and the potassium ion, K and K+, are both called potassium. To distinguish, sometimes we will add the term ion to the end of the positively charged version. Negatively charged ions take the name of the parent atom and change the ending to IDE. We'll have some examples here. Chlorine gains an electron and becomes chloride. So when we talk about sodium chloride, it's not chlorine gas, it's the ionized form of chlorine. Oxygen becomes oxide. The names of ionic compounds begin with the positive ion, also called the cation, and end with the negatively charged ion, also called the anion. So CaF2 is called calcium fluoride. The periodic table will help us with the charges of main group ions. Group 1 always has +1 when it makes ions. Group 2 loses 2 electrons, always has +2. Group 6 gains 2 electrons, and every element in this group has a -2 charge. Group 7 gains 1 electron. They all have a -1 charge. Other monatomic ions, aluminum is +3. Nitride and phosphide, the negatively charged ionic forms of nitrogen and phosphorus, have -3 charges. Now, earlier videos talked about how useful the periodic table is. Here we are. We can tell the charge on different ions by looking where they are in the periodic table. So when writing chemical formulas, the cation charges must cancel the anions. The positive and the negative cancel each other out. Use subscripts on either the cation or the anion to balance the overall charge. Use lowest whole numbers, just like the least common denominator in fractions. Here's some examples. So barium fluoride. Barium, we look at the periodic table, it's got a +2 charge. Fluoride in group 7 has a -1 charge. So the smallest ratio that balances these overall charges, 1 barium to 2 fluorides, BaF2. That's our formula. How about aluminum oxide? Aluminum, we look at the periodic table, it's got a +3 charge. Oxide, 2-. So we want to balance the +3 with the -2. Our common denominator there is 6. So 2 aluminums at +3, 3 oxides at -2 give us a formula of Al2O3. Transition metal compounds. So far, with the main group element, the rules are very good. Everything in group 1 is +1. Everything in group 2 is +2. Now the transition metals are going to shake things up. Okay, I like to call them the bad boys of the periodic table. Rebels without a cause. They don't follow the naming rules of the main group elements, and they're also multivalent. We used that term earlier in the video. They can have more than one charge, depending on what they're bonding with. So, how do we know what charge a transition metal has? We use a Roman numeral. This is called the stock naming system. The number tells us the charge of the ion. Now, for transition metals, the charge will always be positive. So the number relates to a positive charge. Iron 3 has a +3 charge. Vanadium 5, that V is a Roman numeral 5. That has a +5 charge. So we want to name this compound. Oxide, we always know, has a -2 charge. Since there are 2 copper ions, copper must have what charge? It's got to have +1. 2 +1s counteract the -2. The name for this is then copper 1 oxide. So we talked about some chemical naming rules. The main group ions, the transition metal ions. Be sure to look at the videos and the notes for naming polyatomic ions and acids. If you have questions, you can contact me. There's my email address. We have office hours Tuesday and Thursday mornings, 9 to 10 a.m. And you can always make an appointment if those times do not work for you.